Have you ever seen pictures of a data center? You know, those massive rooms with endless rows of server racks, just blinking lights everywhere and a constant hum? It's pretty impressive. That's the engine room of our digital world. But what are all those boxes actually doing? Well, today, we're going to deconstruct the data center and figure it all out. All right, so here's our game plan. We're going to tackle this in 5 key areas. We'll start with the absolute basics, the foundation. Then we'll get into security, managing all that traffic, where the data lives, and finally, how we connect everything without wires.
First up, let's build this thing from the ground up. We're starting with the 2 most fundamental pieces of hardware you'll find in absolutely any data center. These are the real workhorses.
Let's start with the router. I want you to think of a router as the global postal service for the internet. It has one primary job: to take a piece of data from one network, like your office, and figure out the fastest, most efficient path to get it to a totally different network, even if it's on the other side of the planet. Now, you'll often hear that routers are Layer 3 devices. Don't let the jargon scare you. Think of networking like an onion with different layers. Layer 3 is simply the addressing layer. All this means is that routers use IP addresses, the unique street address for every single device on the internet, to make their decisions. It reads the destination address and says, okay, the best way to get there is this way. So if the router connects different networks, what connects all the devices inside a single network? Well, that's where the switch comes in. The switch is the local traffic cop. It makes sure that when you send a document to the printer down the hall, it goes only to the printer and not to everyone else's computer in the office.
And modern switches are incredibly smart. To stick with our onion analogy, they operate at Layer 2, which means they use a device's permanent hardware ID, its MAC address, to direct traffic locally. They do this at lightning speed thanks to specialized chips. Plus, they can do cool stuff like send electricity over the Ethernet cable to power things like phones or security cameras. Some high-end switches can even do the router's job too.
Okay, our network is officially connected. Data is flowing. So what's the very next thing we have to think about? Well, we have to protect it. It's time to bring in the digital bodyguards. And your first line of defense is always the firewall. I want you to picture it as a security guard standing at the only gate into your network. It inspects every single piece of traffic trying to come in or go out, and based on a strict set of rules, it decides who's allowed through and who gets turned away. Now, firewalls have gotten a lot smarter over the years. A traditional one might just block or allow traffic based on a port number, which is kind of like a specific doorway into a server. But today's next-generation firewalls can actually identify specific applications, like YouTube or Facebook, and you can create rules for them directly. They also create secure encrypted connections for remote workers, and yep, they can often act as a router too. Now, besides the firewall, you'll often hear about an IDS or an IPS. An intrusion detection system is like a security camera. It watches the traffic, and if it sees a known attack, it raises an alarm. An intrusion prevention system, on the other hand, takes it one crucial step further. It doesn't just sound the alarm, it actively steps in and blocks the attack before it can do any damage. That focus on prevention is exactly why an IPS is pretty much standard in any enterprise network these days. All right, so our network is connected and it's secure. But what happens when your website suddenly gets 1 million visitors at the same time? How do you keep it from just collapsing? Well, that's a job for the traffic managers. The unsung hero here is the load balancer. See, when you go to a huge website, you think you're talking to one server, but you're not. Behind the scenes, a load balancer is taking your request and millions of others and intelligently spreading them out across a whole group of identical servers. Its entire purpose is to make sure no single server gets overloaded, which keeps the website fast and online for everybody. And here's the brilliant part. The load balancer is constantly checking on the health of those servers. If one of them suddenly fails, maybe a hardware problem, who knows? The load balancer sees it instantly, stops sending traffic to the broken one, and redirects everyone to the healthy servers. And you, the user, you never even have a clue that anything went wrong. It's completely seamless. Another really important traffic manager is the proxy server. This one works a little differently. Think of a proxy as a personal assistant for your internet browsing. Instead of you connecting directly to a website, you tell the proxy what you want, and the proxy goes out and gets it for you. It acts as a middleman. So why would you want that? Well, for a few really good reasons. Proxies can store or cache copies of popular websites, so they load way faster for everyone. They can require you to log in before you can get to the internet, giving a company more control,
And crucially, they can filter content, blocking access to certain sites and scanning everything for viruses before it gets to your computer. Okay, so with all this network activity, all these files, websites, and emails flying around, we're creating an unbelievable amount of data. And all that data has to live somewhere. So let's head over to the central library of the data center, the storage systems. Now, two big players here are NAS and SAN. A network-attached storage, or NAS, is pretty simple. It works at the file level. Think of it like a shared network drive. If you want to change just one word in a giant spreadsheet, you have to download the entire file, make your change, and then upload the entire file again. A storage area network, or SAN, is way more efficient. It works at the block level. To change that same word, it only has to modify the tiny blocks of data that actually changed, not the whole thing. For huge databases and applications, that difference is an absolute game changer. We've spent a lot of time in the wired world, but let's be honest, we all live on Wi-Fi now. So how do big organizations provide that seamless wireless coverage across giant office buildings or entire university campuses? Well, the device at the heart of it all is the access point, or AP. Now, I want to be super clear. This is not the all-in-one wireless router you probably have at home. In a corporate setting, an AP has one job and one job only: to create a powerful, reliable wireless network. That's it. So what is that one job really? Well, this quote nails it. An AP is basically a professional translator. It's constantly translating between two different languages, the language of wireless networks and the language of the wired Ethernet network. That seamless translation is what lets your phone talk to the servers in the data center. But here's the challenge. A big company doesn't have one AP. They might have hundreds of them, scattered across multiple floors and even multiple buildings. So how on earth do you manage all of them without losing your mind? The answer is the Wireless LAN Controller, or WLC. This thing is the brain of the entire wireless operation. It's one centralized box that acts as a single control panel for every single access point on your network. You can manage everything, right, from one place. And the power this gives you is just incredible. You can automatically configure new APs just by plugging them in. You can monitor the performance of the whole network. If you need to make a change, you push it out to hundreds of devices with a single click. It takes what would be a management nightmare and makes it simple. So, there you have it. From routers and switches that build the foundation, to firewalls and load balancers that protect and manage it, all the way to the wireless controllers that connect us on the go. These are the core building blocks. But technology, as we know, never stands still. So the real question is, as all these devices get smarter, more automated, and more driven by AI, what will the data center of tomorrow even look like?